Okay, we're going to do 1.5, solve problems using linear systems. So by the end of today's lesson, you should be able to solve problems that arise from real life situations that are described in words or that are represented by linear systems of two equations involving two variables by choosing an appropriate algebraic or graphical method. So the methods that we know that we've covered in this chapter are using graphing to solve a linear system, using the algebraic method of substitution or elimination. And because the algebraic methods are exact, the graphing method really should only be used when you're expecting a whole number solution. Okay. So some of the steps to solving word problems algebraically involving linear systems. Number one, use a let statement to declare each unknown quantity. Set up equations using the variables if you don't already have the variables or the equations. You need to solve the linear system using the method of substitution or elimination, and you need to write a final statement. I'm going to tell you right now, a check is not required for a word problem unless it specifically says so. But if I just ask you to solve using substitution or elimination a problem where I just give you some equations, I do expect a check as part of your solution. Okay? All right, so we kind of classify these problems, and the first classification we've got here, or the first type of problem, is a break-even problem. So let's see what that looks like. JR's Banquet Hall charges $500 to rent the room plus $13 for each meal. Patty's Banquet Hall charges $400 for the hall plus $17 for each meal. When will both places cost the same? Okay, this is a very, very typical problem that you've seen from grade 9, where you have to find out where, how many meals you have to get to for the cost to be the same. You in grade 9 would have graphed each equation and found the point of intersection. We're going to do this one algebraically, although this one would lend itself to doing it graphically, because we know that it's likely that the number of meals is going to be a whole number, right? Because you can't really have 1.5 meals. Okay, so let's try and set up some let statements. That's our very first step. So what don't we know is the question. And the question is, when will both places cost the same? So we don't know what the total costs are going to be, and we don't know what the total number of meals is going to be. So we're going to say let M represent the number of meals and there's no units for that, and let's use capital C, represent the total cost, and we're really talking about the total cost of either JR's Banquet Hall or Patty's Banquet Hall, and the cost is represented in dollars. Okay, so here I'll just write JR's, so I know which equation is which. So it costs $500 to rent the room, that's that flat fee, and then the variable fee is $13 for each for each meal. So we would have C equals 13M plus 500. And we know that Patty's is going to look similar, but the cost is the same variable, and it's going to be $17 for the number of meals. $17 for each meal, plus $400. So we're trying to solve this linear system, okay, algebraically. Now, it didn't say which method to use, so I personally would be using substitution because we already have a variable isolated. So this is a very nice way to do substitution. All right, so I'm going to sub C equals 13M plus 500 into 2. So I'll just number these 1 and 2. Okay, and so when I take this part here, 1, and substitute it where the c is in 2. Basically all I'm doing is setting these equations equal to each other. So this is going to be 13m plus 500 gets replaced, or it is replacing the c, equals 17m plus 400. So I took this and I substituted it in here. Okay, and then I'm just going to rearrange this. So this is 17m minus 13m equals 500 minus 400. So 4m equals 100. And when I divide through by 4 on both sides, I end up with m equals 25. Okay. And then I'm going to sub m equals 25 into either of our original equations. So I'll put it into 1. This is fine. So I'll rewrite 1c equals 13m plus 500. C equals 13 times 25 plus 500. Is that 325? I'm flying without a calculator here. So C is equal to 825. Well, we'll see when we do our check whether I did the math right on that. All right. Oh, we don't have to check on this one, remember? So I am going to 25 times 4. Yeah, I'm pretty sure that's 325. Okay, so therefore, this is where I would caution you. Always go back and make sure you're answering the question that was asked. So I'm not just going to say the point of intersection is 25, 825. I'm going to say, it says, when will both places cost the same? So it's not asking how much does it cost. It's asking how many meals will we have to serve for the cost to be the same. So we would say, therefore, when 25 meals are served or ordered, the costs will be the same. Okay, so always make sure you go back and answer the question asked. This is not just a matter of putting the ordered pair in. Okay, we have context here. You've been doing this for a reason, because you're answering the question that's being asked of you. All right, let's go to the next one, please. Okay, so we call these relative value reasoning problems. Christian has a total of 8 toy cars and trucks to play with. His birthday is soon. He hopes to double the number of cars he has now. If he does, he will have a total of 11 cars and trucks. How many cars and trucks does he have now? So as you can see, the question mark in the question is how many cars and trucks does he have now? So that should really be our let statements. So let C represent the number of cars he has now, and let T represent the number of trucks he has now. Okay, so he has a total of 8 toy cars and trucks to play with now. So my first equation would be, okay, then C, cars plus trucks, equals 8, because that's the number he has now. And then that's my first equation. My second equation is, he hopes to double the number of cars he has now. And if he does, he will have a total of 11 cars and trucks. Okay? He hopes to double the number of cars he has now. So if he does, he will have a total number of 11 cars and trucks. All right, so total number of later trucks and cars is 11, and he's doubled the number of cars, but he hasn't changed the number of trucks. Okay, he's not getting any trucks for his birthday. He's just hoping he's going to have more cars. Okay, so I look at this equation and I say, this looks like it lends itself really nicely to elimination, but look what it's being asked of me. It's being asked because I presented this graph, I really am asking you to graph this. So c plus t equals 8. Again, I want to make sure this is not an x and a y. This is c and t, and we don't know really, one is not independent of the other. So I can put the trucks, so you can put number of trucks. Now, and we could put number of cars now. So now the cars really, it's like the cars represents the y. So we could put this in c equals negative t plus 8. It's like we're putting it into y equals mx plus b form. And if I did that, oh dear, I have to go up to 8, which I don't have here. So I'm going to maybe try a different method of graphing where I'm going to maybe take a couple of points here. So, whoopsie, this is the independent t, and this is c. So if t is 2, then negative 2 plus 8 is 6. If t is 4, then this is going to be 4. If t is 6, then we've got 2. So I could graph any of these 2 points, so 2, 6, 4, 4, and I could go to another point, 6, 2, and you can see I have a straight line there. Okay, so oh dear, goodness gracious, 6, 2. Stick to. Sorry, I apologize. It's very difficult to draw. I guess I could try and use a ruler next time. Okay, so that's one of the lines, and now I'm going to graph the other one. So this would be 2c equals negative t plus 11, and c equals negative t over 2 plus 11 halves. So again, it's not looking too nice here as far as graphing using slope y-intercept method, but we could try it. We could try graphing 5.5. It's right here, and then we would go down 1 and right 2. Right about there, then down 1 and right 2, and then down 1 and right 2. Okay, and then again I would I'm just going to try using a ruler on my little pad that I have here and see if that works. And of course I can't find a ruler. No, that's not going to help me. Sorry. So I would very much do something like this, and it's looking like, if I went down 1 and over, it's looking like this should have been the point of intersection here at the point 5,3. So I would conclude then I'm going to label the point 5,3. I would put arrows here. I would also label one more point on each line. So this is 2, 6, and 2 and 4.5. Remember, decimals are okay with a word problem. And I know that doesn't look like the point of intersection, but this is the point of intersection if I had properly graphed this. So therefore he has this was the trucks on the X, so 5 trucks and 3 cars. Does that add up to 8? If he doubles the number of cars he has, that'll be 6, plus the number of trucks was 5, and that will equal 11. So that makes sense. So always take a minute to reflect on your answer to see if it makes sense. Okay, and on a test, you know, if I'm asking you to do this graphically and you're not sure, you could always solve it using elimination or substitution to double check your answer as well. Okay. Mixture problems. Matthew's piggy bank contains 308 quarters and nickels. If Matthew has a total of $33.60 in his piggy bank, how many quarters and nickels does he have? Okay, so the question in the question is how many quarters and nickels does he have? So we're going to say let n represent the number of nickels. You don't have to use that particular letter, N, but sometimes it's helpful when you're working on the problem. And let Q represent the number of quarters. Okay, now we have to come up with 2 equations. Matthew's piggy bank contains how many quarters and nickels? 308. And this N and this Q represent the total number of nickels and the total number of quarters. So I know that N plus Q has to equal 308. I also know that Matthew has this many dollars in his piggy bank, and that if he has N nickels, then how much is that worth? In other words, if I had 10 nickels, how do I figure out how much money I have? I have to multiply 10 by the value of the nickel. And we're going to multiply it, because we're talking in dollars here, we're going to multiply it by the dollar amount of a nickel, which is 0.05. So he has 0.05 N. That's how much money he has in nickels. And he has 0.25 Q. That's the amount of money he has in quarters. And the total amount of money is $33.60. Okay, so the value of the money here is what goes in front of the N and the Q. All right. Doesn't say which method to use, but this is lining up nicely for elimination. So let's just go ahead and do that. So I don't have a coefficient in front of my N's that's the same. I don't have a coefficient in front of my Q's that's the same. So I'm going to change the number 1 so that it's the same as number 2. So I'm going to take, I think I'm going to need a calculator. Just hang on. So I'm going to multiply this one by 0.05. I could have multiplied it by 0.25. It doesn't matter. So, so this is going to be 0.05 N plus 0.05 Q is equal to 308. I'll just write it out like this, times 0.05. Now you can go ahead and figure that out on your calculator, and you don't have to show it, but I'm just showing it for your learning purposes. So that's our new equation, and our old equation here that we didn't change to is this one. Okay, so that's number 2. All right, because we didn't change that. So 308 times 0.05 is 1540. So if I really wanted to have shown that, I'm now going to show it as 0.05 N plus 0.05 Q is equal to $15.40. So that's number 3. And number 2, which we didn't change, is that one. All right, so now we're going to perform the operation of subtraction because these signs are the same, S, S, S. Okay, so subtract, 0.05 minus 0.25, just do that on your calculators, but it's minus 0.2 is equal to, and then when I subtract that, I get minus 18.2. And then when I divide both sides through by that coefficient minus 0.2 on both sides, I get 91. So Q, oopsie, I thought I changed it. Q is equal to 91. Okay, well that's good. I'm glad I didn't get a decimal because I can't have a part of a quarter. So far so good. Now let's just figure out what our number of nickels is. And if I were going to go back to any equation, I would go back to the first one, right? Because it's very simple. N plus Q equals 308. My Q was 91, so N plus 91 equals 308, and I usually say sub Q equals 91 into, and then I just say which one, right? Okay, so then back to here, N equals 308 minus 91, so I must have how many nickels? Um, 217, does that make sense? Okay, therefore, let's make sure just to have a quick check back to see what the question was asking. How many quarters and nickels, just in case it was only asking for one. Therefore, Matthew has 91 quarters and 217 nickels. Okay, so the hard part sometimes is coming up with the equations, and then, depending on whether there's decimals or fractions, of course, it can get a little tricky, but the method is the same always. Okay. These ones, it doesn't say, but these are mixture problem. Oh, this is a mixture problem. Was the other one a mixture? Did I call it a mixture problem? Yeah. So that first one was an example of a mixture problem. This next one is an example of a mixture problem as well. Okay, so Mary has a bottle of 5% acetic acid and a bottle of 10% acetic acid. And how much of each should she use to make 215 mils of 8% acetic acid? Okay, so how much of each is the question. So we're going to say let X represent the amount of 5% acetic acid used in mils, because we want to get to 250 mils. And we're going to let Y represent the amount of 10% acetic acid used. Oopsie, in mils. Okay, so our first equation is, okay, if we add these two amounts together, what should we get? X plus Y. If we mix the two amounts, we're trying to make a solution of 250 mils, right? So X plus Y equals 250. The question is, what is the amount that we're going to use, right? So what we know here is that we've got 0.05% acetic acid. So if I multiply the 0.05% times the amount of that particular liquid, I'm going to get like the concentration of acetic acid plus 0.1 times Y, that's going to give me the concentration of acetic acid so far. When I add them together, they have to give me a concentration of 8% times the 250 mils. Does everybody see that? That one's really kind of tricky. So the 5% times the amount is going to give me a certain concentration of acetic acid, right? It's going to be 5% acetic acid. It's going to be, you're adding a 10% acetic acid, but how much of each depends on what your final amount wants to be, because we want it to be 8%. Okay, so 8% times the 250 mils. All right, so if we now multiply 0.04 times 250, or sorry, 0.08. So this is our 1, this is our 2, and again, I'm going to rewrite this with the proper number. So this is going to be x plus y equals 250, and this is going to be 0.05x plus 0.1y equals 20. So I'm going to probably just go ahead, I'll move this. I'm going to change one of them. Number 1, I'm going to multiply by 0.1 this time. I'll change the y's this time. So I will have 0.1x plus 0.1y equals 25. And I'll have 0.05x plus 0.1y equals 20. So I didn't change that one, so we'll call that one 2, and we'll call this one 3. All right, I'm going to do elimination again. I've got the same coefficients here, so I'm going to subtract. So 1.1 minus 0.05 is 0.05x. This is gone, eliminate it, and this is 5. When I divide both sides through by 0.05, I end up with x equals 5 divided by 100. Okay, so I need 100 mils of the 0.05% acetic acid, and that means I need 150 mils, of course, of the 10%, and that will give me an 8% solution for the 250 mils. Okay, so now I'm just going to sub x equals 100 into 1. Now let me just keep an eye on what the question was. Did it ask for both? How much of each? Yeah, so I do need the x and the y. So I'm putting that into 1, so I'm going to say that x plus y equals 250. And I'm going to put 100 here, plus y equals 250. So y equals 250 minus 100, and y is 150, as I said before. So my conclusion, if I can find room, therefore, she should use 100 ml of the 5%, sorry, I'm just going to, acetic acid, and 150 mils of the 10% acetic acid. Okay, so we changed the percent into a decimal here when we were figuring out what the total percent had to be, the total sort of concentration of each one had to be. Okay, So let's keep going here. We got a couple more to do. So these are rate problems. These are probably what I would consider to be the hardest problems. So let's see if we can figure this out. Josie traveled the 95 kilometers from Barrie to Oshawa by car and GO train. The car averaged 60 kilometers an hour and the train averaged 90 kilometers an hour. And the entire trip took 1.5 hours. How long was Josie in the car for, and what distance did Josie travel by train? So we don't know how long she was in the car, and for that matter, we don't know how long she was in the train. And we don't know the distance that she traveled in the car, and we don't know the distance that she traveled by train, only that she went part way in a car and part way on the GO train. So this one's an interesting question. It's a little more complicated. What I would like to go over before we start is our understanding of the relationship between distance and speed and time. So let's just redraw. I know you've done this in grade 9 science, but I'm just going to draw that little triangle that I like to use. Distance, velocity, which is speed, and time. So if you remember this triangle from science class, it was designed to help you remember when you wanted to multiply and when you wanted to divide in order to find a particular variable. So D, you stick your finger on the D equals V times T, they're beside each other. So the distance is equal to the velocity times the time. If I wanted to find the velocity, I stick my finger on the velocity and I can see that its velocity is distance divided by time. Same for T. If I wanted to find the time and I had the distance and the velocity, I'm going to take the distance and divide it by the velocity or the speed to get the time. So how long was Josie in the car for? So I'm going to say let's call it TC, represent the time spent in the car. And if we're talking about 90 kilometers per hour and it's talking about the trip took 1.5 hours, we're going to say in hours. Now, if anybody's from Barrie, Ontario, I know we don't spell it B-E-R-R-Y, just so you know. But so this is a fictitious place, this Barrie. And then let TG, let's call it, represent the time spent on the GO train in hours again. Okay. So the first equation that I can make using these variables would be the total time of the trip. If I add those two times that were spent on each mode of transportation, it's going to be 1.5. So there's my first equation. Now how can I use these variables to come up with something else? Like, what else do I know? I know that she traveled 95 kilometers, but I don't know what the distance was for each. But I do know that what the speed was for each. So the speed was 60 kilometers an hour and the train was 90 kilometers an hour. So if I know the velocity, I can come up with the formula for that. It's distance divided by time. So I know that the time, the distance, I don't know. So the time I do know times the velocity. So the time times the velocity is going to give me the distance. So I could say 60. That's how fast we went in the car, times the time that it takes to go in the car. Okay, so that's the speed times the time is this whole thing represents the distance that the car went. And the distance that the GO train went is going to be represented by the velocity of the GO train times the time on the GO train, which is going to be 90 times TG. And the total distance then is 95 kilometers. Okay, so I know that's tricky. Again, for this one, you could either use substitution or elimination. I would probably just stick with elimination here because they're set up nicely for it. So we're going to multiply the top one by either 60 or 90, you pick. So if I multiply by 60, I get 60 TC plus 60 TG equals 60 times 1.5, which is 90. And then, so we'll call that 3 because I've changed it into an equivalent equation. And then the next one is going to be 60 TC plus 90 TG equals 95. All right, and that's still 2. All right, whoa, subtract, because these are the same. We get 0 here, and we get minus 30 TG equals minus 5. And TG then is 5 divided by 30. I'm just going to write that, or no, I think I will just do it as a decimal. Remember the rule that we have is you can have it, no, it doesn't come out nicely, 5 divided by 30. So I think I will then just leave it for now as 1/6 of an hour, 1/6 of an hour, which is which we could say in minutes. So we're just going to leave that for now. All right, so that's the time spent on the GO train, and now I want to sub that in. Sub TG equals 1/6 into 1. I just want accurate answers here for now. I know that might be a little confusing. So TC plus 1/6 equals 1.5, which is 3/2. And so TC is equal to 3/2 minus 1/6. Just go ahead and do that on your calculator. So that's going to be like 9/6 minus 1/6 is 8/6, which is 4/3. Okay. So therefore, let's look at the question before we answer it. How long was Josie in the car? So we really saw we needed this one here, the car one, right? Not the GO train one. So, you know, in reflecting on this answer, we could have avoided having to do this part if we had just isolated for the other variable, right? So if we had, not isolated, but if we had eliminated the TG from the beginning, we would have ended up with the TC just right off the hop. So we could have done that in hindsight. Okay, so therefore, Josie will spend 1 1/3 hours. Is that okay? Or if you want to be less exact, it would be for about 1.33 hours in the car. Okay, so that's the first part of the question. The second part of the question, so that's all for A. What distance did Josie travel by train? Well, the distance was represented here, right here. These two parts represented the distance for each of the modes of transportation because it ended up being 95. So if we know the time that she spent on the GO train, we can just multiply it by 90 to get the distance. Okay, so B. So we know that the distance on the GO train, say, is equal to, no, we should probably, I'm just changing my mind here, I'm just going to use a let statement okay, if I'm introducing that. So let DG represent the distance Josie traveled on the GO train. In kilometers. Okay, and so DG is going to equal 90 times TG. We already established the GO train was going 90 kilometers an hour, and whatever time she spent on it was represented by T of G. We figured out what TG was. That's going to be 90 times 1/6 of an hour, which is 10 minutes if we were working in minutes, but because this is 90 kilometers an hour, we have to use hours. So this is DG, so DG is 90 over 6, which, we'll see what that comes out to. It comes out to exactly 15 kilometers, right? The distance was in kilometers, so therefore, she traveled 15 kilometers on the GO train. Okay, that wasn't an easy problem, right? I get that. You've got to remember your relationship between distance and speed and time. That little triangle helps you sometimes. And just remember, I think the key thing here is that the units have to match. If this is time and this is time, then this is time. And if this whole thing comes out to distance, and this whole thing comes out to distance, then this has to be a distance. Okay, you can't be adding speeds and times and getting distances. This times this, the 60 kilometers an hour times the time, gives you the distance, okay, when you multiply those two together. So take a minute to check that always. Okay, so we're going to do the very last question. I know this is a super long video. I'm sorry. So this is a trickier, I think, one as well. So I hope you can pay close attention. A canoeist took 2 hours to travel 12 kilometers down a river, and the return trip against the current took 3 hours. What was the average paddling rate of the canoeist, and what was the speed of the current? So the thing that you have to think about is when you're going on a river, there's upstream and there's downstream because of the current. So if you're going downstream, you're going with the current so that you're going actually pretty fast. And if you're going the other way, if you're going upstream, then you're going against the current, and you're actually going slower than your paddling rate. So this canoeist is paddling at an average speed the whole time. And when he's going downstream, he's actually going faster than his average speed because he's got the benefit of the current with him. But on the return trip, the opposite is true. He's going to be going slower than his average paddling speed because he's got to contend with the current that's against him. Okay, so you have to think about those things in this type of problem. So what was the average paddling rate of the canoeist? So we are going to let R represent the average paddling rate of the canoeist. We don't know what his speed was. Canoeist. And we're going to say it's in kilometers per hour. Okay. So that's something we need to find out. The other thing we need to find out is we do need to know the speed of the current. So we're going to say let C represent the speed of the current, and again we're going to use the same units in kilometers per hour, and we're always going to talk about downstream, so it'll be a positive speed. Okay, so let's see if we can think about what's happening as he goes downstream. So we'll just put that as kind of our focus here. So we want to come up with an equation that represents what's happening as this canoeist paddles downstream. Well, what do we know? We know that there are two things or forces at play, if you will, if he's going downstream. He's going to go at a certain speed because of his paddling speed, and he's going to have another speed that has an effect, and that's the speed of the current, right? So his speed is going to be the rate of the current. That's the average paddling speed plus the rate of the current, and that is going to give the total rate. And the total rate is the amount of time that it took and the amount of speed or the distance that he covered. So he covered 12 kilometers in 2 hours. So his rate of travel was, I'm just going to write it as 12 divided by 2 for now. Okay, but of course that's going to be 6. Does everybody understand that? Okay, this is his rate of paddling. This is the rate at which he was being pushed by the current, and that total rate was the rate that it took for him to get down the river, downstream. Okay, upstream. Okay, so it says here the return trip against the current took 3 hours, and some of you might ask, well, how far did he have to go on the return trip? And it took 3 hours, but how far did he travel? And he actually, because he is going, it's a return trip, he's going the same distance back that he went there. So it's still 12 kilometers that he's traveling. So his return trip, he was paddling at the same average speed, but this time he was battling the current, right? He was against the current. So it reduced his speed by the amount of the current. And this speed that he traveled, well, it took him 3 hours to go 12 kilometers. So this time it was 12 divided by 3. Okay, so we'll just rewrite those. R plus C equals 6. That's the first one. And then R minus C equals 4. That's the second one. Now I know for some of you that's going to be hard to wrap your head around how to come up with those equations. You might have to view the video a couple of times for these, or just try a couple of examples and see how you do. Okay, they're tricky, but once you get the equation, look at this equation. It's so simple, right? What should we do? Add or subtract? Well, we've got choices. We could add and get rid of the C's. Let's just see what we were being asked to find: the average paddling rate and the speed of the current. So we need both. So I'm going to add to eliminate the C here. I get 2R equals 10 and R equals 5. And then I'm going to sub R equals 5 into, I don't know, into 1. It doesn't matter. They're both so easy. So R plus C equals 6. And 5 plus C equals 6, and C equals 1. So make sure you're including the units. Make sure you're answering the question that was asked. You're not just saying the solution is 1/5 or whatever, right? You are saying, therefore, the average, go back to your let statements if you don't know what these represent. So the average paddling speed of the canoeist is my R, which is 5 kilometers per hour, and I've got my units there in my let statement too. The speed of the current is 1 kilometer per hour. Okay. That's it. Thanks for your patience.